will have a tutorial about how to use Keras and TensorFlow to build a convolutional neural network and to have a multi-class classifier that can classify the MNIST dataset. So the code will be running on Google Colab. Google Colab is a very convenient way to run your code. It's all your code will be run online. It has all the packages installed for you, and if you need more packages, actually you can install yours. It also offers you GPUs, which will make you run much faster. So to start with, we will begin by importing the packages that we will need to run the code. So to point out a few, we have here the TensorFlow. We'll be using the TensorFlow, the Keras, sklearn, NumPy. So these are some of the main packages that we will be using to build our classifier using CNN. And if these packages are imported correctly, we'll get this message. And also we are using this function to get the version of the TensorFlow we are using, and we will also print it to the screen. So to start with, all packages are imported, and we are using TensorFlow version 2. Then for convenience, the Keras comes with all, not all, but some of the benchmark dataset already available for you. You don't need to worry about how to will you get these datasets. So we will just use MNIST will be our tf.keras.dataset.mnist, and I will use this MNIST to load data to get the MNIST dataset. And not even you will get the dataset as is, but you will get it also split to train X, train Y, and test X, test Y. So this will be your training dataset, and this will be your testing dataset. So this is input, output, input, output. These are for training, and these are for testing. One of the things that most of the people do is to normalize the value of pixels. So instead of having the pixels from 0 to 255, you'll be having them from 0 to 1. But we are dividing the dataset, the train X by 255 and the test X by 255. Here also we'll be setting the number of epochs to 5. The MNIST dataset is not a very challenging problem, so usually 5 epoch is more than enough. And to understand more about our data, to see actually what do we have in the labels, we can use the sklearn.utils.multiclass.unique labels, and it will return to us the labels that we have in our dataset. So if you don't have the dataset installed, it will be downloaded to your computer. So now we have it installed, and we know that these are the labels that we are dealing with from 0 to 9, digits from 0 to 9. Okay, to know more about our data set, this function, draw grid of images from image data. This is a convenient function you can always use to visualize your data. So let's run it. So it will give you exactly what shapes. So it's single channel images that have handwritten numbers, handwritten digits from 0 to 9. Okay, other thing is that we need to have the shape of your training dataset, so train X and the testing dataset in a proper way for Keras. So we need to use something called np.expand dimension. So if you run this, you will find that now your dataset is 60,000 by 28 by 28 by 1, and here is the test dataset is 10,000 by 28 by 28 by 1. So what we did by np.expand dimension is that we got this shape. So we have 60,000 images. Each image is 28 by 28 and have only one channel. And the testing dataset, we have 10,000 images. They are 28 by 28 pixel and with only also one channel. So we need this exact shape, like a tensor rank 4, so that we can use this in our network. So now we have our data as ready for training. Let's define our neural network. It's very straightforward. We are using sequential Keras. We have a convolutional layer with 32 filters, 5 by 5 kernel with the activation of Rulu, And then we have a max pooling with the kernel 2 by 2, then another convolutional layer with 32 filters size 5 by 5, ReLU activation, then another max pooling layer. So all of this is trying to capture the important features of the image. We do flatten so that we'll have a very long vector of features, and then we will feed these features to a dense layer of size 512 with a ReLU, and then to a final dense layer of size 10 because we have 10 classes, and the activation is softmax. So this is how we defined our convolutional neural network in Keras. Let's start by running it, and okay, it's created successfully. The next thing you need to do is to compile your model. So when you compile your model, you will inform Keras of some of the important aspects of your model. So here we are telling Keras that we are using the Adam optimizer. You can use SGD optimizer, RMS prop optimizer, Adam optimizer. So we are using the Adam optimizer, and our loss function will be the sparse category cross entropy, and the metrics will be the accuracy. And so let's run this compilation, and okay, model compiled successfully. Next, this one is the most important thing. We are training our network. We are training our model. We are giving it the train x, train y, and the validation dataset test x and test y, and we are setting the number of epochs for training. So let's train our model. This will probably take some time, but we are running on a GPU. So it's running now. It's showing you the loss for the training and for the loss for the training dataset and the accuracy for the training dataset. You see it's continuing in increasing, and the loss is continuing to decrease. These actually are the number of steps that you have per epoch. So we have 1875 steps per epoch. This depends on your batch size per epoch. Okay, and while it's training, let's leave it a while till it's trained, and then we will continue again.